Hello and welcome to the Siemens Industry Software Incorporated webinar. My name is Matthew and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's session. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed into the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now let me introduce today's presenters. With us today is Noam Ribon, the Senior Consultant for Siemens Digital Industries Software, and Sunil Chabra, the Global Portfolio Development of Manufacturing Engineering at Siemens Industries Software. To read more about our presenters, please look at the speaker bio window right next to the main presentation window. And with that, let's get started. Noam, welcome to today's event. And with that, I will pass things along to you to begin.
Thank you, Matt. And thank you for joining our webinar for electronics manufacturers. Today, we'll share with you how the digital twin can improve your production utilization and performance KPIs, or key performance indicators. We'll also share how the digital twin can speed up the process of designing new facilities from the ground up or reconfiguring production lines in existing facilities. We spend a lot of time with our customers, and we've hosted many C-level and senior executives from companies like Lenovo and Foxconn to discuss the trends, challenges, and opportunities in the industry. With electronics going into everything, one key trend was apparent. Much of the electronics industry is consumer-driven. Bosch, a high-end appliance manufacturer, mentioned recently in one of our public forums that embedding electronics into their appliances was imperative to maintaining their premium brand status. This trend means more electronic models, each for a smaller batch of products. Electronic manufacturers now face the challenge of meeting capacity and the increased overhead that comes with smaller lot sizes. Tight labor conditions add a challenge of their own. For small and medium-sized manufacturers, seizing this growth opportunity requires the ability to maintain production KPIs despite of these challenges. Larger manufacturers will also need an ability to build up quickly to meet growing demand. In this webinar, we focus on two areas in our smart manufacturing solutions portfolio. During our session, we will share three examples of how we at Siemens use our own tools to achieve the results we are discussing. Let's open with a short movie demonstrating how Siemens numerical controller Nanjing, China uses digital twins to improve its KPIs.
From the first idea to realization, every step was digitally supported to ensure best performance. SNC New, a digital native factory. 1. Value streams are simulated to optimize production performance. 2. Different site concepts are evaluated to minimize transportation efforts. 3. Layout alternatives are defined for space optimization. 4. Production lines are planned and digitally optimized before implementation. 5. Even the building design and construction progress are digitally planned to limit later changes. 6. The digital twin and its data are all managed in Team Center. The factory was simulated even before the first concrete was poured. Resulting in up to 20% productivity, up to 30% volume flexibility, up to 40% space efficiency, up to 50% faster material replenishment, and a lot more. In only about 2.5 years' time, we are realizing a truly digital native factory. To be continued.
Siemens, ingenuity for life.
Of the two areas of our smart manufacturing portfolio, we start with discussing utilization and performance, and follow with a discussion about planning of new facilities or reconfiguring existing ones. It is common knowledge in the industry that utilization and performance is negatively impacted by a high-mix, low-volume environment. Labor shortage does not help the situation. The way your shop floor operates is changing. In this first segment of the webinar, we will show how a digital twin can help you adapt to this change and increase utilization and performance KPIs. I will hand our discussion to our industry expert, Sunil. Sunil?
Thank you, Noam. Thank you for the introductions. Good morning, good afternoon, everyone, depending upon the time zone you're in. I see a lot of familiar names. Hello again, and thank you for taking the time to join this webinar. So before I dive into how the digital twin helps in improving utilization and performance, I would first like to touch upon OEE and different inputs. We have a total calendar time, a scheduled time, available production time, which may include some planned downtime, running time, which constitutes of some unplanned downtime, and that could be operator related, machine related, material related, quality or operation related, theoretical throughput, actual throughput, which may include some performance loss, actual output, and finally good output, which accounts for quality loss. The focus of our webinar is on unplanned downtime. As mentioned earlier, unplanned downtime constitutes of operator assists, machine issues, material shortages, quality and operations related issues, and in some cases, the unplanned downtime could be 50% or greater of your total running time, especially so in a high mix, low volume environment where the line is waiting on the offline setup area to complete setups. In such scenarios, OEE is gated by setup preparation and changeover and not by the production line. I like to call these shops as being in the business of changeovers and not in the business of building boards. So what we would like to do today is simulate how changes in production schedule, material inventory, resource availability impacts line utilization, so we can prepare and strategize and manage these changes better as they come along. We've created a simulation model that simulates activities in the offline setup area and simulates a production line. In order to understand how activities in the offline setup area impact line utilization, I would first like to discuss inputs to our simulation model. Our first input is production schedule, a bill of material for each assembly, setup list or grouping of assemblies if you're grouping assemblies, material inventory, machine runtime for each assembly, and lastly, the manpower or resource availability. We have the ability to pull in all this information once you have specified a production schedule by connecting to various systems. Once we have the required inputs, the model estimates the setup time for a given job. It also simulates how the line or how the jobs will run on the line, accounting for material replenishments or resource availability. The whole goal over here is to compare setup time versus runtime and to see if the offline setup area will be able to keep up with the production runs. That way, the production line is not waiting on the offline setup area. I've put together a very simple Gantt chart to help us visualize runtime versus setup time. In my example, the line is already producing assemblies A1, A2, and A3, and the offline area is preparing my next setups for A4, A5, and A6 assemblies. The line is scheduled to complete producing A1, A2, and A3 by noon, whereas the offline setup area is scheduled to complete setup preparations for A4, A5, and A6 by 11 a.m. As soon as the line completes production, because the offline setup area has already completed setup preparation, we are able to change over to A4, A5, and A6 without any waiting time whatsoever. While the line is running A4, A5, and A6, my offline setup preparation area starts preparing setups for A7, A8, and A9. Well, in this example, you can see the runtime of assemblies A4, A5, and A6 is a lot less than the setup preparation time for A7, A8, and A9. So what's going to happen is the line will be waiting on the offline setup area to complete the next setup before it can change over. This causes unplanned downtime, and they all add up significantly in a high mix, high changeover environment, causing utilization loss. I like to call it death by a million cuts. Our goal is to help visualize how lines are running, how setup area is preparing setups, put the two together to understand if sequencing of assemblies will cause any utilization loss. Now we can also run multiple scenarios to see if adding an additional resource to the offline setup area would help speed up the offline setup process and reduce any line waiting time. At this point, I would like to hand it back to Noam so he can demonstrate the simulation model and show us what the outputs look like. Noam, back to you.
Thank you, Sanil. Great discussion. Let's go right to the demonstration. For this demonstration, we will use a basic configuration. We have the offline setup, where according to the setup list, reels are loaded into feeders and placed on an SMT table or a trolley to be later carried to the SMT pick-and-place machine. We have one SMT pick-and-place machine. Runtime can be set individually for each assembly. In our case, we will use a general line rated speed of 30,000 components per hour. We have our staging area where SMT tables or trolleys are placed while the SMT machine is running. And last, the reel reload where material replenishment is performed during runtime interruptions. Now for our inputs. Material inventory with the list of reels, each with its SKU and quantity of components. The list of PCB assembly orders. The amount of each PCBA and its BOM or bill of material. And jobs or setup lists. In our case, we have 3 jobs, job 1, job 2, job 3. Job 1 has 3 PCBAs, job 2 has 2 PCBAs, and job 3 had 3. All this information is imported from the shop information system. This includes the setup list of components serving to prepare the setup for each job. In our case, the simulation will calculate it. we have one worker. Let's start the simulation. Job 1 was already prepared in the previous shift, so the SMT pick and place could start running at the start of this shift. The worker is now preparing the setup for job 2, loading reels into feeders and into the SMT table for job 2. When the setup is ready, it can be placed in the staging area or carried directly to the SMT machine if it is waiting, as is our case. Our worker will continue to prepare the setup for job 3. In reality, we do not need to watch the simulation. It can be simply fast-forwarded to the end of job 3 or the last job that we have. The simulation is complete. The 3 jobs, less the first setup, will take 18 hours and 36 minutes to complete. The simulation only took a few seconds. Let's visualize our KPIs. Looking at our Gantt chart with the offline setup on the top lane and the SMT on the bottom lane, we can immediately see that our machine, our SMT machine, is waiting for the offline setup. Details of the length, the duration of the setup and the SMT runtime, as well as the starting and stopping time of each job, whether on the offline setup or on the SMT machine, can be viewed in detail in the Gantt chart. We can use this information to test alternatives, for example, changing job sequencing or adding resources or workers. The simulation can be further used to optimize our utilization in a more automated fashion. We can also look directly at our utilization KPI. Not surprisingly, with the waiting, our utilization is only about 70%. Checking our worker efficiency, though, we can see that we're only at 85% utilization. In summary, the digital twin can help you identify ways to improve your utilization and performance KPIs. I will take a brief pause here. It would be interesting to learn which of the areas, for example, material replenishment or manpower, you feel impact your utilization KPI. Feel free to type up your thoughts in the chat. Sanil's discussion and our demonstration focused on the SMT part of the PCB assembly process. As reflected in this image, the digital twin can scale to improve production KPIs across additional parts of your operation and the interdependencies between them. Examples are through-hole insertion and box build. Back to Siemens numerical controls. A case study performed there was reported in a white paper by Jay Goraja, Longtim Chen, and Stefan Krug. A digital twin was created for manual insertion lines and wave soldering. This is a mix of labor and automation. The KPI was capacity, sometimes also referred to as performance. Using the digital twin, the capacity study predicted that the delivery will be much lower than forecast. Using the same digital twin, an improved strategy was identified, surpassing the forecast by increasing capacity. We will conclude the utilization and performance segment with a case study from Siemens Manufacturing in Karlsruhe. Siemens MFK is one of Siemens AG production sites. It produces controllers, switches, Wi-Fi routers, industrial PCs, and other electronic devices in numerous versions and various bed sizes. With their high degree of product variance, smaller lot sizes, and fluctuating order volume, their biggest challenge is line balancing. The manual and automated processes have to be coordinated so that all devices can be manufactured on the same line without waiting times, as quoted by Bernd Bastian, a Siemens MFK employee. The solution was to combine production and value chains and create a digital twin of the plant to simulate the entire production area. This resulted in achieving 100% quality, 100% delivery performance, 100% waste-free production, and increased output. And now to our second area, planning for new facilities and reconfiguration. When building new facilities, as Siemens Numerical Controls did, or significantly reconfiguring existing ones, planning how equipment will be laid out is a significant undertaking. A 3D digital twin will cut down planning time by providing a clear and unambiguous view of the proposed layout and its alternatives. The same digital twin can later serve you in production as a starting point for the topic we just discussed, the digital twin for utilization and performance. With a digital twin, you can plan, detail, and present your layout. We saw how our Siemens Numerical Controls used the 3D digital twin for clearly articulating several layout alternatives while in the planning phase, for detailing, and for presentation and collaboration. In the next movie, we will show an already detailed layout and demonstrate how a digital twin can speed up the process of designing new facilities from the ground up or reconfiguring production lines in existing facilities. We're looking at a detailed digital twin of the facility. It includes multiple areas such as SMT lines and box build. This type of visual provides clarity for collaboration and decision making. The digital twin is not just a visual representation of the layout. It is intelligent and holds detailed information about your plan. On the left, we see a list of equipment making up your facility, each line item associated with its visual counterpart. In our scenario, a decision has been made to add a machine enclosure next to the one already on the floor. Doing so is as fast and simple as selecting the enclosure from the library, dragging it, and snapping it in place. Adjusting dimensions is just as easy. Layout designers can also switch between the 3D and a 2D view. Adding equipment in the 2D view is just as easy as it is in the 3D view, dragging from the library and snapping into place. In this case, changing length is done directly from the parametric menu. The layout also supports moving mechanisms to their different positions. The ability to do so can mean not having to relocate the equipment after discovering it collides with objects on the floor as it moves. Since the layout is intelligent, it is possible to run reports displaying results visually for quick comprehension. In this case, the report colors distinguish between suppliers and can even provide a count. In summary, the digital twin will cut down planning time by providing an efficient way to create or modify the layout, as well as a clear view of its intent. That same digital twin can later serve as a starting point for the production digital twin. We shared two areas in our smart manufacturing portfolio: how the digital twin can increase your utilization and KPIs, and how it can accelerate new plant designs. The smart manufacturing portfolio is broad and covers many additional areas. Here are some of the results our Amberg plant was able to achieve with smart manufacturing. Every year, the factory manufactures around 16 million SIMATIC products with a quality standard of 99.9999%. Over 120 variations are built per day, with one product dispatched every second, and some 350 changeovers are taking place for 1,200 different products. Thank you for joining our webinar today. You are invited to join us on September 30 to another Smart Manufacturing webinar. Learn how transforming big data into smart data helped our customer minimize errors and save production time. The Siemens numerical controls and Siemens MFK case studies, as well as the registration link for the Advanced Analytics webinar, can be found in your resources panel. This concludes the prepared presentation. Feel free to contact us for extended discussions. Now I will hand it back to Matt to introduce the Q&A session. Matt?
Thank you so much for that great presentation. And now let's get to the Q&A. We have some questions that have come in from the attendees, so we're going to move into answering those now. If we don't get to your question, don't worry, we will have an answer for you following the webinar. Now for our first question. Okay, I actually see two questions that seem to be related to a similar topic, so let me start with the first one. The planning movie showed various types of machines. Do we need to have CAD on the machines in order to start?
Very good question. We get it often. While it is nice to have the detailed 3D CAD representation of the make and model of the equipment, it's not critical. The machine can be represented by maybe a more simplistic model, as long as the dimensions match, and those dimensions can be typically received from the equipment manufacturer. Labeling, as you may have noticed in the movie, will help with the overall comprehension. Library models for general equipment like workbenches come with the application. Many cases for industry-specific equipment, a simplistic form is sufficient. Those can be modeled in the application, and some of our customers actually invest in creating parametric models that allows them to have increased efficiency as they can reuse those models, different length, different parameters as we saw in the movie.
Great, thank you for that. Okay, and a similar question. Do I need to have CAD on the machines in order to start?
Again, a good question. Utilization and performance analysis doesn't really require the 3D CAD of the equipment other than perhaps dimensions of the factory layout when you have workers walking for distances and such. Out-of-the-box representations, which that's what you saw in the movie, can be used with just as accurate results. When CAD is available, it can be applied for nicer visualization, as we saw in one of the following slides to the movie. Of course, if the 3D layout is already available from the layout team, this layout can be readily used by the simulation, and the availability greatly reduces the time to create the simulation model from scratch.
Great, thank you. Okay, next question from the audience. How accurate can a digital twin really predict my performance?
Valid question, and an important one. At a recent benchmark on a rather complex production line, the digital twin achieved a 99.77% accuracy, almost 100%, when comparing its predictions with the throughput measured in production. Of course, the accuracy will really depend on how well the model will reflect your production line and the quality of the information that you feed into the model. Our experience is that our customers know their production lines, they know the information, And as they work with the digital twins, they develop a better sense and understanding of the type of information that's needed to really provide accurate results. Ourselves, Siemens, as well as our partners, can help with that, building that understanding as well.
Thank you. Okay, next question. I am a medium-sized business. My resources are limited. Is the simulation used by small or medium businesses, or is it just for large companies?
Thank you. I really appreciate the question. I realize now the three movies that we shared were shared about Siemens, and Siemens is a large company, but as a matter of fact, at least one of the businesses that we shared information about was a medium business on its own as a unit. So the answer is yes, medium-sized businesses use our simulation with good returns on investment. The solution is obviously packaged for large businesses, but it is packaged for medium businesses as well, always according to needs and capacity. On the resource side, meaning your resources who will use the simulation, our partners can augment your need by providing ready-to-use digital twins, so your resources don't have to invest the time there. And instead, your resources can really focus on using the digital twins for analysis. And of course, when some changes are needed, you move some machines, you increase capacity, your resources will be able to handle that as well. So to summarize, the answer is yes. The solution is used by medium businesses.
Great, thank you. Okay, next question from the audience. Can the simulation model automatically detect if there is waiting time between a production run and next setup?
Yes, absolutely. While the Gantt chart is a very nice and a very useful visual aid, it clearly shows when machines are waiting. You see those gaps between the bars. As a matter of fact, it's not necessary. The intelligence is built as the simulation progresses, and the machine wait times, for example, between the setup time and the run time, are recorded and available in the simulation anyway. A specific query can be pulled in lieu of the Gantt chart just with those jobs that require attention, for example, and have a list of the wait times so you can decide which ones you want to really focus on. As we mentioned in the demonstration, since the information is available, the simulation can be and typically is taken one step further and automatically run a set of alternatives that you predefine. For example, let's take a look at 2 workers. Let's look at this type of sequencing, etc. And at the end, present a report with the one alternative that's promising the highest utilization KPI, for example. For example, I can measure for the lowest waiting time of the machine if I want to, or any other KPI for that matter. So the simulation model that we've seen was for demonstration purposes to kind of understand how simulation works, but really the way our customers use it is typically in a much more automated fashion, detecting specific information that they need to optimize their production on.
Great, thank you. Okay, next question. Can you add an efficiency factor or account for other machines that are the bottleneck when estimating build times?
Well, that is a very good question. It's, as a matter of fact, could be in the essence of what we call the digital twin. The accuracy of the digital twin is as good as its model. So as a matter of fact, if other factors impact the utilization of, for example, the SMT pick and place machines, those factors should definitely be added. The model we showed isolated the SMT machine for demonstration purposes, but if production is fine-tuned to feed the SMT machine, meaning everything else is working just to make sure the SMT is continuously running, and if the only major bottleneck is the offline setup time, yeah, the model we shared might be a good place to start, and would provide a good ROI. Of course, additional machines and offline setup areas can be added to reflect your actual production. For example, in the MFK, the Siemens MFA case study we mentioned, which is also available to download from the resource panel, the complete production process was modeled just because of those tight interdependencies between areas, and this kind of hopefully answers your question. If other factors should be added to account for other machines that may pose a bottleneck in addition to this offline setup.
Great, thank you. Okay, and here is our last question. Does the simulation model account for feeder inventory?
Yes, it can. If feeder inventory, and I think you've seen something in the simulation, maybe that's not what you're looking for or in the demonstration. We were accounting for actually real and component, SKU component inventory. The feeders themselves, the mechanisms, I guess, the feeders were not accounted for. We're assuming there's enough of them. But if the feeder inventory has an impact on wait time, you're waiting for feeders to return from production, absolutely it should be included in the model.
All right, thank you. And that was our last question. So we are going to wrap things up right there. So Noam, thank you so much for being here today, and Sunil as well. And of course, thank you for taking the time to answer some questions from the audience. We'd like to also thank our audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with your colleagues. And lastly, please take a moment to complete a survey which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we will talk with you soon.